So hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about solving radical equations. So we are done with performing operations with radicals and simplifying radicals. We will be using our knowledge about simplifying radicals and performing operations with radicals in solving radical equations. So to start, let us remember that if we are given square root of x and we want to change this radical expression into exponential expression, we can write this one into x raised to 1 half. So how did we get 1 half? 1 half is taken from the exponent of x here, which is 1, which is in the numerator, which is 1, and the assumed index here, which is 2. So as I have said in my previous video, that if a radical does not carry an index, that means the index is 2. So that's why we have here x, the variable x, which is our radicand, is raised to 1 half. Now, if we want to eliminate the radical symbol in a radical expression, we will just simply raise the whole expression to 2. That's why we have here the square root of x quantity raised to 2. In this case, we can change this radical square root of x into exponential, so that is equal to x raised to 1 half, as I have said here. So we have x raised to 1 half, and we square this expression to 2, that's why we have here the 2. Then by using power of a power, we'll just multiply this exponent here and the exponent outside the parenthesis. So that's why we have here 1 half times 2 is 2 over 2, and 2 over 2 is equal to 1. That's why we have here the x, which is assumed to have an exponent 1. So in this case, we now eliminated the radical symbol in this expression. So if we want to eliminate the radical symbol in our radical expression, we just simply raise the radical expression to the power which is equal to the index. And how about if our index is 3, just like here, cube root of x? So in this case, if we want to change this one into exponential expression, of course, this is equal to x raised to 1/3. So our 1 is the exponent of x here, and our 3 is the index. So that's why we have here x raised to 1/3. Now, the same idea here, if we want to eliminate the radical symbol in this expression, we have cube root of x, we can raise the whole expression to 3, which is equal to the index. In this case, if we are going to change this one to exponential, so this will give us x raised to 1/3, which is the cube root of x, and we raise that to 3, so that's why we have 1/3 times 3, we have 3 over 3, and 3 over 3 is equal to 1, which is the exponent of x here. So in this way, we already have cancelled out the radical symbol. So let's proceed to our example. For example, we are given square root of x is equal to 3. So here, in solving radical equations, we need to eliminate the radical symbol in the equation. So how to eliminate the radical symbol in this example? We have square root of x is equal to 3. What we need to do is to square both sides of the equation so that we can eliminate the radical symbol at the left side of the equation. So this shall become square root of x quantity raised to 2, since our index here is 2, so that's why we raise this one to 2. We square both sides of the equation, so we have 3 quantity squared. In this way, we can cancel out now the radical symbol and the exponent, just like the example that I had presented earlier. So we now canceled out the radical symbol and the exponent. So what shall remain in the left side of the equation shall be the variable x and the square of 3, which is 9. So therefore, our x is equal to 9. So to check if this answer is correct, we need to go back to our original equation, which is square root of x equals 3. And then, we substitute the value of x, which is 9, in this equation. So that's why we have square root of 9, since our x is 9, equals 3. And of course, we know that the square root of 9 is 3. So therefore, 3 is equal to 3. So therefore, this answer is correct. Now, let's proceed to our next example. For example, we are given the square root of x minus 3 is equal to 2. The same we have here, square root, that means we have the index 2. So what we need to do is to square both sides of the equation to eliminate the radical symbol. So we will have the square root of x minus 3 quantity squared is equal to 2 squared. So this time, we can cancel out the radical symbol and the exponent 2. So what shall remain at the left side of the equation shall be x minus 3. And 2 squared is of course 4. Then we use addition property of equality since this is minus 3, so we add 3 here. Of course, we will also add 3 at the right side of the equation. So negative 3 plus 3 is of course 0, so that means only x shall remain at the left side of the equation because negative 3 is already cancelled out. Then that is 4 plus 3. So therefore, x is equal to 7, that is 4 plus 3. Now to check if this answer is correct, we go back to our original equation, which is the square root of x minus 3 is equal to 2. Then we substitute the value of our x, which is 7 in this equation. So we have square root of our x is 7 minus 3 is equal to 2. Then 7 minus 3 is of course 4. That is square root of 4. And we know that the square root of 4 is 2. So therefore 2 is equal to 2. Since this is balanced, so therefore our value of x is equal to 7, which is correct. Now let's proceed to another example. For example, we are given the square root of m is equal to 4 times the square root of 2. Still, we have square root, that means the index is 2. So therefore, in order for us to eliminate the radicals here, we have the radicals. So we square both sides of the equation since these are square roots. So we have the square root of m quantity raised to 2 is equal to 4 square root of 2 quantity raised to 2. In this way, we can cancel out the radical here. And of course, we can cancel this out, this radical here, and the exponent 2. So what shall remain at the left side of the equation shall be the variable m. Now, how did we get 16? Since 4 is outside the radical symbol, so therefore we need to square 4. That is 4 squared, that means 16. And since we already have eliminated the radical here and the exponent 2, so what shall remain shall be 2. Then lastly is to multiply 16 times 2, which is equal to 32. So let's proceed to our checking. We go back to our original equation, which is the square root of m is equal to 4 square root of 2. We substitute the value of m, which is 32, so that gives us square root of 32 is equal to 4 times the square root of 2. Now, if we are going to analyze this radicand here, we have 32, and 32 is not a perfect square. So therefore, what we need to do is to simplify 32 and factor out 32 in such a way that one of the factors will give us a perfect square. And when we factor this out, we can have these values. We can have these numbers, 16 times 2. When we multiply 16 times 2, that gives us 32, and 16 is a perfect square. Then, we get the square root of 16, which is 4, and place that outside the radical symbol. So therefore, we have here 4 times the square root of 2. Since 2 is not a perfect square, so it shall remain inside the radical symbol. So we have 4 square root of 2 is equal to 4 square root of 2, which is a balanced equation. So therefore, our value for m is correct. Now another example. For example, we are given this equation. Square root of 2a over 3 minus 2 is equal to 0. This time, we have here a fraction, and of course, we have here minus 2. And our constant is negative 2. Since this is negative 2, we will use addition property of equality, so we will add 2 at the right side of the equation, and this will be eliminated. So the equation becomes the square root of 2a over 3 is equal to 2. That is 0 plus 2, which is 2. And we already have cancelled out minus 2 because it is plus 2. Then we also add 2 at the right side of the equation. This time, we need to eliminate down the radical symbol. Of course, still this is square root. So we need to square both sides of the equation. So this shall become square root of 2a over 3 quantity squared equals to squared. Then, of course, we eliminate the radical and the exponent. So what shall remain is the fraction 2a over 3 equals the square of 2 is 4. And next is, of course, since this is a fraction and this is a whole number, this has an assumed denominator 1, we cross multiply. So that is 2a times 1, the assumed denominator of 4 here, which is 1, so that is 2a. Then 3 times 4 is 12. This time, since we have 2a here and we are only going to solve for the value of a, of course, we need to divide both sides of the equation by 2. This way, we can cancel out the coefficient 2. So what shall remain in the left side of the equation shall be a. Then 12 divided by 2 is 6. So therefore, the value for a is equal to 6. Now, let's proceed to our checking. We go back to our original equation, which is the square root of 2a over 3 minus 2 equals 0. This time, we substitute the value of a, which is 6. So therefore, we have square root of 2 times our a is 6. That's why we have here 2 times 6. We copy over 3. We copy minus 2 equals 0. Then we simplify. 2 times 6 is 12. Then we copy over 3 minus 2 equals 0. 12 divided by 3 is, of course, 4. And the square root of 4 is 2. So that means 2 minus 2 is equal to 0, which is equal to 0. So therefore, our answers are correct. So that's it. I hope you have learned something from this video. Then if you have questions, please do not forget to comment down below, or you can message me through my Facebook account, which is found in the description box. So thank you and God bless.